Good evening, everybody. My name is Christoph Kralj, and I'm come from the University of Vienna. I would like to start with the motivation, why we created TagRefinery and why we are working with tags. Everything started with music, so I'm pretty sure most of us in the room love music. And there's a lot of music, and I'm always looking for new kind of bands and new things, and it's really hard to find new music. And especially, I think most of us know Spotify, and we look at the facts, they have like more than 30 million songs, and we say like they have on average like 3 minutes. It's like more than 170 years of listening just to each song once. And even worse, they add like around 20,000 songs a day, which means like 31 days per day of new music. So we need something to find new music. The most specific way of doing this is searching for artists, searching for an album. But there it's really, really hard to find new music. On the other side, there's radios, playlists on Spotify, or even a genre. And there's the problem, it's really open-ended, so you have less control what you actually get. And in between, there are tags. They have the opportunity to constrain the space in the way you actually want. What are challenges using tags? So there are two kinds of tags. There are expert-curated tags, and there are social tags. I'm really talking here about social tags. And social tags means everybody can write something, and they can write whatever they want. And when people are allowed to write whatever they want, they really do this. And there are a lot of problems come from there. The most obvious ones are spelling errors. Sure, they have really, really funny things. But also they are like word forms. So you have like the word favorites, and then you have like really permutations of the word which are for an algorithm actually different. Then what people really like is adding or removing characters they shouldn't add or remove. Like the last example here, they just concatenate a lot of words. Then there are topic-specific words. Like in this case, those are two genres, screamo and pianoblast, and they are really music-specific words. Then always when you're working with text, there comes the problem of word ambiguity. Like is it apple the fruit or is it apple the company? And last but not least, there's the problem of multiple languages. So in the last of M dataset, we had like 5 languages, and even sometimes in one tag, there were at least 2 languages. So how to handle all those things? What would be a way of preparing this data to use it to explore something or to create a recommendation service finding new music? The most obvious way and the most flexible one is using programming. Other ways would be using like OpenRefine or using something like Wrangling. What do all of those have in common? So either they have no interface when you're programming, IDEA doesn't count, or they have like, in the other case, like a spreadsheet-like interface, and we all love spreadsheet-like interfaces. The other problem is when you want to do more complex operations, you need some kind of scripting or programming. And at the end, when you're like a novice user and you have no idea what you're doing, you've never text processing, never done any kind of text processing, they are unguided. So you're like, where should I start? What are the problems? What should I care of? So from there, let's jump to requirement analysis. So the whole project was built over multiple months, and we had like 12 participants from novices like designers to real experts like lecturers in natural language processing, which we interviewed in a really informal way in this kind of think out aloud study. During this phase, we realized the most obvious dimension of users is it a novice user or is it an expert user? Sure. But then we find out also there's another interesting dimension. Some users really love to rush through a workflow and just wanted to get some result out of it. And other users really like spend a lot of time in each step and try to figure out what's going on here. That's the reason we created TagRefinery, to prepare the tags in a way and that that it could be used later on. And we provide 2 different modes, a guided mode and an advanced mode. This is a view, this is one step out of the guided modes. It has always a navigation bar at the top. Then there is a progress bar, so the user can always see where in the current workflow he is. And on the right side, there are summary statistics. In the middle is the core part of the guided view. It always starts with a question, which is really informal, and asks, do you want to do that? And below there is the option, yes, I want to do that, just go with default. The quick users really was jumping, yes, yes, default, default, default. or no, I don't want to do that. If the user is not sure what's going to happen here, they can mouse over the bold words to get additional information or read below the additional information. When the user decides to say, yes, I want to do this step, in this case, yes, I want to reduce word forms and I want to remove spelling errors, another view opens. Don't focus too much, I explain this view later, but the view of the current step opens and the user can now manipulate the thresholds which should be manipulated at this point. This is the second view, it's the advanced view. It was actually built first, but we realized novice user couldn't use it at all, actually. Here, it has just a tab-like interface, and the user can jump to any point in the workflow and really say, like, I want to do some spell correction, or no, I want to do some pre-processing and just fix this one specific step. There are also additional parameters which are only available in the advanced mode, which give the user even more control of the whole workflow. And again, when the user opens a view, it's the same view as in the guided view. So when a novice user starts out with the guided mode, and he can easily later use the advanced mode because the views and the namings are all the same. I want to give a quick overview of the workflow. The workflow consists of 3 parts. It's a pre-filter part, a spelling and multiwords part, and a polish and savage part. To get more details, please read the paper. I just give you the goals of each specific part. The goal of the first is text normalization, which is like tokenization, lowercasing, bring the words into good shape, and temporary dataset reduction. This means when the datasets get really big, the following up step couldn't be not in real time, so you can filter it early on and bring the tags later on in again. The second part is the spelling and multiwords part, which is the core of the whole workflow, where the goal is really simple and clear. It's improving the quality of the data. And here the user in the loop plays a critical role because he has to fix the thresholds and check the words out. I want to show now the view I showed early on, which is the view of the spelling correction. It is composed of 2 parts, left and right, which is always a slider and a list. When we look at the left side, the idea is the user can select a threshold and say every word above this threshold is treated to be a correct word. And every word below is not correct. Those two elements are linked, so the user can either check the word quality from the slider or from the list. And word quality is a popularity-based measure, which is derived from the input dataset. When the user has chosen his threshold on this side, the right side updates, and the user can now choose a similarity threshold. That means in this case, every word above a similarity of 70% is going to be replaced. The first row shows like there's jazz with 6 C's and jazz, and they say like, oh, this should be replaced. And the user has the possibility to exclude words because some words are from a syntactic point really next to each other, from semantic really different, like alternate or alternative. Here I want to share another insight we got while visualizing text in specific. We started out with word clouds, but the literature shows a lot that word clouds really only work when you want to show an overview. But in this case, we have this kind of search task where the user the list worked out much better than the word cloud because the user can go through the list, can sort the list, can search within the list, which provided more opportunities for the user. The last step of the workflow is so-called polish and savage step. The goal of this step is to reduce the final set of tags. This is especially useful when the data is intended to be used in a recommendation service, like you want to do a smartphone app and you can't use 200,000 words in a smartphone app. So it's like there is the opportunity to reduce the tags, and the second part of this step is salvaging information out of unused rows or not used rows. For the evaluation, we had 2 different kinds. We had a usability evaluation, where we get 6 participants, which were all computer science students, which had no prior knowledge to text processing, but had like statistics and computer science. they had to solve a task. They had to do the get 300 most important tags out of a data set. And only 300, and it was like 10,000 were initial words. The screens were captured. At the end, there were informal interviews. So they asked what worked out, what didn't work out, and they had to fill out an SUS questionnaire to show how good is the usability of the tool. The second part are case studies. We had 3 participants which brought their own data set and had their own specific problem. And the real cool thing is TagRefinery provided them with new insights about their data. While they were exploring and while they're moving through the data set, they saw like things like, oh, this kind of noise I haven't seen before. Oh, why is this looking like this? And I want to highlight one specific case study, which was the most successful one, which is called TagFlip. TagFlip was published last year at IOI and got a Best Paper Award. And the idea of TagFlip is to explore a music space in a novel way using tags. In this case, we see like there's a song, The Scientist from Codeplay on the right side. It has this kind of tags. And the user can, by flipping those tags to the right side, say, oh, the next song should be rock, and it should be alternative, and it should be a mellow song. Or you can easily say, no, I don't like a mellow song, please give me a love song. To look at what TagRefinery did, how it helped is TagRefinery pre-processed all of the data for this project. The raw data set had around 250,000 unique words and around 5.4 million song tag pairs. The users ended up with 358 tags from the initial 250,000. And by just using the normal workflow without salvaging, they ended up with around 1.7 million song tag pairs. With help of salvaging, we were able to push it to 2.3 million song tag pairs, which is an increase in around 31% of final rows which could be used in the recommendation service. Okay. With that, I would like to summarize our contributions. The workflow, we created a workflow for cleaning tag spaces. We created 2 types of interface which target novice and expert users. The whole tool was successfully in preliminary evaluations and in the TagFlip project. With that, I would like to say thank you. And if there are any questions, I'm happy to answer them. And those are the links to the tool, so they are on GitHub, so everyone can just use it. Thanks.
Questions from audience? Actually, it sounds like your tool is very, looks like it's feeding something, it's doing for something else.
Yeah.
Not just digesting tags. So can you give us a little bit of a hint that what this could be useful and why?
The idea is clearly that when we look at papers, normally clean data just emerges out of nowhere. So nobody explains how do I come up with a clean data set. And the tool is really intended to bring a data set into shape, to use it for something else, like in the case of TagFlip, we used it for recommendation service. And so the raw data wasn't usable, and really the goal is data pre-processing. Data, that's the reason of the title, Wrangling, tag wrangling.
Any other questions from audience? Okay, it's a last session. I see reduced energy from audience. Yeah, let's give a hand.
Thanks.